Well, hello. Thank you for being here. This evening is an important milestone for our company. It's literally been many years in the making, and we're very excited to be here in Seoul, and I'm delighted and honored that you're here to share this moment with us. So the journey begins quite a few years ago. As Sammy mentioned, Leemon and I have been working together for 25 years. We started doing machine learning research together. We taught computer science together at the academy. We've done several startups. At the end of the last startup that we started back in 2012, Leemon decided that he wanted to solve a really hard problem. Specifically, he wanted to figure out how to create a distributed ledger algorithm that solves two problems simultaneously. First, he wanted to achieve the limits, the theoretical limits of what can be achieved in terms of security. And then second, concurrently, at the same time, he wanted to maximize the performance. Historically, those two goals have been at odds. You can improve the security at the expense of performance or maximize performance by sacrificing security. Leemon wanted to solve both and maximize both at the same time. I remember many evenings in Austin, Texas, at a particular Starbucks that Leemon and I would frequent, spending those evenings talking about his latest ideas on how to solve this problem. And there were so many dead ends, so many ideas that he would think of and pursue, and it turned out to not work for one reason or another. In 2015, he solved the problem. Today, we call that the hash graph. It's an algorithm. It's an alternative to blockchain, totally different from blockchain. But importantly, it's a fundamental advance in the state-of-the-art of distributed ledger technology. He did achieve the goal. He solved the problem of having an algorithm that is both something called asynchronous Byzantine fault tolerance, that's the theoretical limit of what can be achieved in terms of security, and at the same time, fantastic performance, the best that one can do in terms of the algorithm's performance at the algorithm level. So we decided, you know, if we look across the market at what's happening, Bitcoin had made a market. When Leemon started the work, he didn't start the work in 2012 because he saw what was happening with Bitcoin. He started the work because we wanted to improve the way the internet works. There are some fundamental problems in the way the internet works today. He wanted to be able to make it possible for us to reach out and grab a slice of cyberspace and be able to work together and to play together and to exchange goods and services with one another without the requirement of having to trust a third party with our privacy and our data. That was the goal from day one. Had nothing to do with Bitcoin. But through those years, of course, Bitcoin took off, made a market. And so in 2015, we decided he's solved the problem. Let's take Hashgraph and take it to market. So we started a company. It's called Swirlds. And Swirlds was focused on not public ledgers, but private ledgers, permission networks. At the time, Leemon and I were unknown in the industry. We didn't have a reputation in this industry. And we were using a brand new algorithm that no one had heard of. So we understood, in order to achieve our goal, our vision of where we wanted to take the technology and how we wanted to improve the internet, we had to start first with permission ledgers. And we did so. And we got traction. And we got some significant customers in the United States. And there came a moment in time in 2017 where we realized we have it. We have enough traction. We have software written. We have testimonials. let's begin to execute on this vision of what the internet should look like. We recognized there were some fundamental problems or obstacles in the category of public DLT, and we decided we needed to solve those. So what are those requirements for adoption, mainstream adoption of public distributed ledger technology? There are 4. Number 1, performance. I mean, we all know, the entire industry knows that the performance of first and second generation public DLTs is just not sufficient. There's not that many things you can do at 7 transactions per second, right? We needed orders of magnitude improvement in that performance. Number 2, security. If it's going to be the case that these public ledgers are being used to transfer ultimately trillions of dollars of value, then you have to assume that the network is going to be attacked. And therefore, you have to start with the very best building block that one can achieve, because if you do, then the house that you build looks very different. It has a different set of properties than if you don't. So you have to achieve asynchronous Byzantine fault tolerance as the foundation for the platform that you're building. Thirdly, stability. The entire market is made up of open source platforms. That's been good and bad. Part of the downside is that we all assume that the existing public ledgers are going to hard fork and split into competing platforms with competing cryptocurrencies. That causes a serious problem for mainstream adoption. When you have an application running on top of one of those platforms, and those platforms hard fork, the state of your application splits along with the new network. You have duplicate copies of your state, one on the original network, one on the new network. The software that's used with your application, the client software that runs on computers and smartphones, when it connects to the network, it doesn't know which is the official version of the application. And transactions now begin to happen on both. And the state of your application diverges. It creates chaos. And because of this, it's not going to be the case that enterprise managers, that considering spending millions of dollars to build an enterprise application on top of one of these networks, will take the risk. It's just too risky. That problem has to be solved. And we address that, and I'll explain how in a few moments. If you can solve these 3 problems, performance, security, and stability, the final piece is governance. What is the organization? Who are the people that are managing this platform? The way we're addressing governance is fundamentally different than what we've seen in the public networks today. We started with the goal of building a governing body that is the most decentralized, most representative of all use cases in all major markets. It's a council of 39 global blue-chip organizations, cross-sector, geo-distributed, and term-limited. We want representation from 18 sectors of the market, not a bunch of financial institutions. There'll be a couple. But 18 sectors represented. Geo-distributed. We don't want all of the representation to be from a single jurisdiction. And then finally, the council members are not members for life. They can serve up to 2 3-year terms for a total of 6 years before having to move off the council. That's our approach to governance. This is the software stack. At the bottom, you can see that there's the Hashgraph consensus algorithm. It's the foundation that makes all of this possible. On top of that, we have 3 core services. Cryptocurrency with native support for micropayments. When I say micropayments here, I mean that it's possible for one user to make a payment to another user of a fraction of a cent. maybe a 100th or even a 1,000th of a penny, and do so economically, and do so at the native level. We're not talking about adding additional levels of additional layers on top of the foundation. This is at the very bottom of the stack. No need for a Lightning Network or side chains. Cryptocurrency, smart contracts with support initially here for Solidity, and then finally file storage. With that set of services, it becomes possible to build arbitrarily complex distributed applications. That's what this platform is meant for. So we introduced this concept, our vision for what a public ledger should look like, a year ago in New York City. Let's take a look. Raising the bar for the industry, we are Hedera. We consider this a mission to maximize the internet to what it can be tomorrow.
'Cause I'm the new best thing, better than you've ever seen.
Fair, fast, and secure.
Trusted transactions, whether that's voting or consensus.
First of all, it's not fairness, it's fairness of ordering, fairness of timestamps, fairness of access.
We open up a whole new genre of applications.
With the old and end with the new, I sparkle like a ruby pot of gold for you. All sugar and spice, you know I'm not nice, but I'll send you down the road straight to paradise.
The Hedera Hashgraph technology platform has implications that stretch all the industries on planet Earth.
I'm the new best thing.
Since March of last year, we've accomplished an awful lot. That kicked off what we sort of think of as phase one of the effort. After March, we did two things. We went on a fundraising effort, and we raised $124 million. And we began to engage potential council members. In August, we launched what we call the mainnet. We stopped taking money. There'll be no more investment in the platform. And we launched the mainnet, and we coined 50 billion tokens. That kicked off phase two. With phase two, we began to circulate the legal documents that were required for joining this council. This council is an LLC. It's a corporation. Originally, there was a single member, Swirlds. With the addition of council members, it's an organization, a corporation, made up of the council members themselves. We launched our APIs for the platform. And then in October, we had our first developer conference and a global hackathon that took place simultaneously in 8 cities around the world. Let's take a quick look at that. I could not be more excited to have you here with us to kick off our first annual developer conference, Hedera 18. We've just wrapped up our first 8-city, 2-day global decentralized hackathon.
We're trying to get everything aligned, have the game theory right, to have the economics right, so that you don't have a tragedy of the commons where things are overused.
Thing. I'm the new best thing, better than you've ever seen. I'm the new best thing.
We now are in phase 3 of our effort. And with this phase, we're testing the mainnet. We launched a community test program, which we've now completed. And yesterday, we had our first council meeting, and we had a ceremony where I countersigned the legal agreements expanding the organization from 1 member, Swirlds, to now 6 by adding the next 5. And tonight, we have our we make the announcement of those initial 5 members that have joined Swirlds in the organization, and we are hosting here, and you're a part of, our first annual Hedera Annual Assembly. So where do we go from here? What's the future look like? It's pretty simple. We're testing the network. We're testing it relentlessly. We've already completed phase 1. We had a goal of getting 5,000 user accounts, and we achieved that goal in 2 weeks' time. Those users, those early beta testers, took some actions that helped us test the network itself. Specifically, they downloaded a Chrome extension into a browser that serves as a wallet. And then they used that to go and read articles from a website that we created that had original content. It's a real website with real articles. And each article that they read, they were able to use the browser, the extension in the browser, to make a micropayment for reading the article. And they did so seamlessly. And we demonstrated all of that. And of course, we rewarded them for doing so with micropayments of our cryptocurrency. It's called the H-bar. Phase 2 is going to be to expand the testing program to 100,000 accounts. If any of you have not been able to participate in phase 1, this will be your opportunity to participate in phase 2. And we'll be launching phase 2 in a few weeks. We already have more than 300 organizations building dApps, actual applications, on test networks today. And the network of nodes will grow over time. When you launch a network like this, you don't launch at scale. And of course, we aren't either. But we are launching. The nodes are being operated and managed by the members of the council. Initially, it will just be the members of the council. But in the coming months and years, we will expand that through a sharding solution to enable anyone that wants to run a node in the network. We expect tens of thousands of nodes, if not more, to participate in this global Hedera network. So we've given as much thought to the topic of governance as we have the technology itself, because we think that both are equally important. If you don't get governance right, then the project will fail. So when we talk about governance, what do we mean specifically? Well, in this case, we're talking about the governing body making decisions related to these items. What are the features that are going to be added to the platform? When will those features be added to the platform? What are the fees that will be charged for the use of the services on the network? What will we pay as incentives to those that are running nodes in the network? And then, of course, there's management of treasury that has to be considered. And when we talk about this, there are different models that can be used for governance, and they each have pros and cons associated with them. We need a governing model that is capable of making very complex decisions and is trustworthy. So there are some extremes that can be considered to understand this. One extreme, perhaps, is a dictator. One individual or organization that is making all of the decisions. In that case, it's quite possible that they can make very complex decisions, but they're highly susceptible to corruption or bribery. In another model, perhaps a direct democracy, it's possible to maximize trustworthiness but often very difficult to make complex decisions. An alternative is a medium between the two, a council that has a few representatives, but enough that the organization as a whole is trustworthy, but specialized, and they have the skill set to make very complex decisions. But it doesn't matter what model you use if there is no way for the governing body to enforce the decisions that they make. If there's no opportunity for the governing body to compel the users of the network to adopt the decisions, then you have weak governance, no matter which model you use. Most of the market uses expert counsel. If you consider the major platforms, there are a handful of people or organizations that are making complex decisions. But because everything in the market is open source, and at any time, if some members of the community decide that they no longer want to adopt the changes being proposed by the governing body, they can just fork the platform into two separate platforms and separate cryptocurrencies. There is no way to compel the market to adopt the changes, and therefore you have weak governance that devolves to chaos over time. And of course, that's exactly what we're seeing. And it has a tremendous negative impact on the market. We've seen that impact over the past months. So what do? Is there a way to create and enforce strong governance, and what's required? Well, the answer is yes. What's required for strong governance? Number one, you have to, as a governing body, be able to enforce the changes that are being made to the software with the nodes. You have to be able to compel the nodes to adopt the changes. Number two, the client software in the field, the client software that's using the platform, has to be able to know if the node that it's connecting to has the latest software. Has the node actually adopted the changes that are specified by the governing body? And then finally, the governing body has to be able to prevent forking of the state of the platform for the reasons I've previously discussed. If you can solve these problems, then you have the opportunity to actually govern in a meaningful way. But if you don't, then you don't. Hedera has strong governance. We have two different approaches to enabling the requirements that I just mentioned. There are technical controls that Leemon will touch on that we can use to ensure that the platform itself will not fork, and that ensures that the nodes simultaneously upgrade the software at the same moment in time. And then we have legal controls. The Hashgraph algorithm is patented, but we're using that patent to bring stability to the platform in a way that nothing in the market can. The patent and IP will be used as a defensive mechanism. There's no license required to use the network. It's just like Ethereum or any of the other platforms. When you make API calls, you pay for those API calls using the platform cryptocurrency, using HBARs. And the source code itself, with version 1, will be open for the entire world to see. It will not be a black box. It will be transparent. So in many ways, it's very similar to open source, but in a fundamental way, it brings stability to the platform that will be unmatched in the market. So with that, I'm very proud and honored to be able to announce tonight the first set of council members that are joining us. The first 5. Deutsche Telekom, DLA Piper, Magazine Luiza, Nomura, and Swisscom. Several of these members are here with us tonight. They will be on stage and sharing information with you. Again, it's my honor and privilege to be working with them and looking forward to future announcements where we bring the additional council members on in the coming weeks and months.
We are in the dawn of a new decentralized era, where people who don't know or trust each other can securely collaborate and transact online without the need for an intermediary. For distributed ledgers to go mainstream and enable this vision, there are 4 issues that must be addressed: speed, security, stability, and governance. Hedera Hashgraph is the enterprise-grade public network that addresses these challenges. The underlying Hashgraph consensus algorithm offers speed and scalability, fair ordering, and best-in-class security for mission-critical applications. Hedera is a platform built on and built for trust.
You need a governing concept. And because blockchain systems are about trust, well, somebody has to set the standard for trust.
Hedera aims to achieve a truly decentralized governance model. The Hedera Governing Council is an elected group of highly diversified, leading global organizations, committed to supporting the development and growth of the Hedera public network.
In our point of view, the game changer in Hedera's governance approach is the diversity of its members.
Comprised of the world's most innovative companies across different industries and geographies, the Hedera Governing Council will chart the path for the Hedera platform and public network. Their responsibilities include hosting and maintaining initial network nodes, establishing a governance framework for global markets, and overseeing the software run by hundreds of thousands of nodes at scale, and for the overall direction of the Hedera platform's codebase.
We decided to join Hedera Hashgraph, but not only join, but being a counselor on the Hedera Hashgraph network, because it's important for us to influence the future roadmap.
The Governing Council will play a crucial role for this emerging sector, creating the best practices and guidelines that will serve the industry for decades to come.
But we're all going to be able to get together and share that sort of global best practice knowledge on a series of interesting and challenging questions about the future of this technology and how we can help frame a governance around it.
Hedera Hashgraph goes beyond blockchain with a fast, fair and secure distributed public ledger governed by the world's leading enterprises and made for developers, creating a trusted and empowered digital future for all. What future will you build?
I want to emphasize that these governing members will actually govern. The organization has committees. For example, a technical steering committee, legal and regulatory committee, marketing and PR, and many others over time. And the governing council members, where they have expertise, contribute that expertise to the committees. The committees have oversight of all the business functions of Hedera as an organization. And of course, the governing members have use cases. They already have ideas for exactly how they would like to use a public network to realize real value, both in the top line and the bottom line. And so we're honored again to welcome our first 5. We look forward to filling out the rest of the 39 through the remainder of this year. And we thank you all for being here with us tonight, and I look forward to speaking with you afterwards. Thank you.
Another big applause for Mance Harmon. So Mance, by the way, is definitively one of the most technical people that I have met. but he's actually the non-technical founder of Hedera Hashgraph. And you have seen already Dr. Baird in some of the videos. Mance has been speaking about it. I'm not going to spend too much time because the man is sitting right there. Dr. Baird got his PhD from Carnegie Mellon in 2 years and 9 months. That's the fastest ever. Not just that, he's a full professor at the Air Force Academy. He also holds many adjunct professor roles in other prestigious universities. He's written hundreds of published peer-reviewed journals in machine learning, in computer science, in mathematics. He has many patents. So I had the pleasure of sitting next to him at a certain dinner. And I am definitely sitting next to one of the smartest people on this planet. I'm trying to think, okay, what kind of conversation am I going to strike up, right? So I just pick a topic that is dear to my heart. I start talking about one of the books that I've written. And I look at him, and he is grabbing on to every single word that comes out of my mouth. Genuinely curious and genuinely humble. Despite being one of the smartest people on this planet, a leader in the industry, I have never met a person also as humble as Dr. Baird. So please, ladies and gentlemen, join me in welcoming Dr. Baird, co-founder and chief scientist of Hedera Hashgraph to the stage. Thank you.
Thank you very much. Oh, thank you. It is so good to be here. I've never been to Korea before. It is beautiful here, and everyone has been so warm and welcoming and had such hospitality. Thank you very much. It is wonderful to be here. I have appreciated it. And, as we heard before, I love the food. It is fantastic. So we are here today to talk about what we are doing here, about the company that we have, about the technology we have, about this ledger. But I'd rather start just by talking about the vision. And actually, your introduction was very kind. I have not published that many papers. You are very much too kind. But I just want to tell you how it all started. What I was thinking of at the beginning, what we were thinking about, what we were trying to do, and just kind of take you along with us on the journey of how we got to where we are and what we were really wanting to do. So let's talk about just kind of the idea. The idea was that it really should be possible for anyone to just kind of wave their hand and carve out a piece of cyberspace and create a world of their own. Just kind of create a place where you can create things, where you can connect with other people, where you can have trust in it. This was the idea. So it had nothing to do with ledgers and cryptocurrencies and all those things. The idea was just, this is how the internet should work. When I want to have something, I should be able to create a world of my own, anytime you want to, without asking anybody for it. Just create this thing, and you could create things like documents inside this world. And you can invite friends. And you could collaborate in doing things together, doing work together, building new things together. And you could communicate with each other. And you could play games together. And you could interact, buy and sell things. You could interact in other ways. This was the idea. Anyone should be able to, at any time, create a shared world that you all interact in and that you all are involved in. And then when you've invited people, they can invite people, and soon it grows to a dozen or 100 or 1,000,000. It should grow as big as you want. And it doesn't live on a server somewhere. It just kind of lives out in cyberspace. And if your computer is erased, you somehow get the information back. You don't have to think about it. It's just kind of natural. And then if you can create this shared world, you set it up to run a certain way, and it's trustworthy. The rules of the world are enforced. There's no dictator. You don't set it up where you are in control of everything and you can delete anything and you can control it all. No, you set it up the way it should run, And everyone can trust that it will be running that way. If it was a game, then everyone has to play by the rules of the game. If it is a Wikipedia kind of thing, everyone follows the rules for how you create and who can create things and who can delete things, and everyone can maybe vote. Maybe you set it up as a democracy where you can vote on what happens. Or if you want to set it up as a dictatorship, you do that, and if people don't like it, they don't have to join it. You should have the freedom to create whatever you want, and then people can trust that it will be running correctly. But not just one shared world. What we should be able to do is anyone can create more of these worlds, and they should all interconnect with each other. And so maybe you want to create a stock market, and your stock market is trading stocks and trading things with and paying for them with a cryptocurrency. And there's another one that's the cryptocurrency. Up there in the upper right hand is maybe Hedera, our public ledger that does the cryptocurrency. And so in your various worlds, you're using the things from the other ones. Maybe one of those is a Wikipedia, and then another one is using those pages and displaying them, and it becomes part of it. And they interconnect with each other. And the interconnections all have rules that you can trust, and you understand how it's going to happen, and it is trustworthy, and no one central authority is in control of it all, and no one person can destroy it all. And we can work together and get things done, and that we can play together, and we can connect with each other and socialize together, and that we can have things that are clearly defined, cryptocurrencies or records that we know are true, and do it fast. For some of these applications, you need a lot of transactions per second that you're doing with the speed and security. So that was the vision. And that's what it started off on, was just trying to solve as an interesting math problem, how could you do this? And that was what drove the requirement to be fast, fair, and secure. It wasn't just, hey, wouldn't it be cool to be fast, fair, and secure? It was the actual math problem was, how can I do fast, fair, and secure so that you can create this kind of a world for just how the internet works? Because if you could solve this math problem, then you could make the very nature of what the internet is be different. That was the original goal. That was the vision for where we want to get. And so that's what we did. This led to the creation of the Hashgraph algorithm, which, as Mance has told us, led to swirls, and then finally, with that validation, to Hedera Hashgraph. And we launched that to the world last March, and yesterday we finally signed the paperwork and actually created a governance council that will be governing it properly. It has been a long journey, and we are now at the very beginning. Now comes the fun part. And now comes the part that we've started to build something that now you can build on top of with us. And so I can't wait now to have you be part of us on this journey, and that you can be building the future. We'll make a nice foundation for you, and you can build on top of it, and you can build the future. This is the goal. So what is this then? What is it that we are going to do differently? I mean, how is Hashgraph different? I mean, there's lots of blockchains. There's lots of different ledgers out there. What is going on here that is different? And so there's some things that are interesting, and we've already heard about that. It is fast. It, in some ways, the consensus achieves kind of the limit of how fast you can be in a single shard. And it's interesting to look at the math of it all. But basically, things spread exponentially fast. You're using almost the limit of 100% efficiency of the bandwidth limit, and you get consensus about as fast as the laws of mathematics would allow. And so in a very fundamental way, it is very fast. And you get latency within a few seconds, and it's finality as well. So this part's actually very important. In this ledger, if you want to transfer cryptocurrency to someone, you say, I want to transfer cryptocurrency. You sign a transaction, you send it into the ledger, and within a few seconds, we have finality. You know that it went through. And the person you gave it to knows that it went through. And you're never wrong. There's not like confirmations that each make you a little bit more sure, but you never really know for sure. It's not like that. You reach finality. There is a moment where you know that this transaction went through. It actually happened. And we never have to reverse. And in other ledgers, people will say, well, if you get to 6, maybe that's good enough. I'm pretty sure, although there have been rare cases where even with 6 confirmations, it still has to revert back. You discard them and it was a different fork. There have been even worse cases. But here, within a few seconds, you have finality. You know for sure. So that's important. And for some use cases, it doesn't matter, but for some use cases, it's very important to do this. The kind of collaborative vision that I was describing, you have to have this kind of thing. Also, if you want to go to sharding, which means breaking up the network into pieces to get even more speed, you have to have this at the core so that you have finality within a shard so that the other shards can then rely on the first shard. We'll talk more about that, but this is important. But speed doesn't do you any good if you can't trust it. The whole point here was trust. And so are we trusting? We're trusting that you can't double spend, but we're trusting more things too, including new things like fairness. So what is this? When you put a transaction into the system, you ultimately get consensus on it from the whole network agreeing, and the whole network agrees on the time at which your transaction officially reached the network. It is a consensus timestamp. And it is not just the opinion of one node. It isn't like there is a miner that puts a timestamp on the block and that's the official time when we all sign off on that block. It's not like that. It's more like your transaction, when it goes into the network, spreads like wildfire, exponentially fast until everyone has it. It's a gossip protocol, so it's very fast. And then we find out when each of the computers first received it. And we can take that list of times and take the middle one. We put them in order, take the middle one, the median. And that is when your message reached half of the world, when it reached the majority of the world. That is the consensus timestamp. And we have strong mathematical guarantees that we will come to the same consensus. We will all agree on this timestamp, and no one computer can corrupt it. No one could make it be 1,000 years in the future or 1,000 years in the past. Already we're seeing people start to have applications where this matters. Atomic swaps between ledgers, timestamps matter. You can have contracts where you say something happens at a certain time and the timestamp matters. You might want to prove to a court that you released information at a certain date. If you had a way of getting a proof, which we also have, we'll talk about state proofs, the timestamp matters. With Hashgraph, which is what Hedera is built on, you can trust the timestamp to be fair. And when we put a bunch of transactions into the system, they're all put in order by their timestamp. So you can trust the ordering to be fair. We have fair ordering of our transactions. Now, if I'm just paying people, does it really matter what order? Yes. Because if I only have one H-bar in my account, but I try to pay one H-bar to 2 different people, I've done double spend, the first one will work. The second one won't. So it matters which one was first. Or if you're playing a game, if there's an object in like a massively multiplayer online game, if you're playing an MMO, there's an object there, a value. You try to pick it up, and I try to pick it up. It matters who was first. And if you really were first, you want the game to give you credit for being first. It'd be bad if I could cheat and somehow convince the game that I was first when I really wasn't. And so we need fair transaction ordering. If you're in a stock market, stock markets depend on things like fair ordering. It would be a disaster if you didn't have fair ordering. And so we want to have fair ordering, otherwise no one would use a stock market. And we have that. And we have fair access. No one's in control. There is no leader, not even taking turns being a leader. So there is no one leader who could stop your transactions from getting into the system. All of the computers in the system are equal, and you can talk to any of them and say, please take my transaction, and it can do it. If you want even more reliability, you can give your transaction to several of the computers, and if even one of them is honest, you're good. You have fair access. It is very hard to stop you from getting access. If an attacker is trying to shut down the network and they can shut down a few of the computers, you still have access. Use any of the other computers. Any of the other computers would help you. So fairness is important. It is a little bit important for a few of the applications running today on ledgers, and it is crucially important for future applications like the ones I've been mentioning. But we aren't just fast and fair, we are also secure. A ledger has no point if it isn't secure. If you have to give up everything, you can give up everything except for security. There's no point in having a ledger if it isn't secure. This is why blockchain was invented, and this is why distributed ledgers exist. It's for security. But it turns out there are different levels of security. Some are more secure than others. There are different ways you can be secure. Secure means you can survive attacks, but there are different kinds of attacks. And so what do we have? We want to be secure in the strongest way possible, which turns out to be this thing called asynchronous Byzantine fault tolerance, ABFT. What does that mean? Well, if you don't have ABFT, maybe you only have BFT. That's almost as good. And if you don't have that, maybe you don't have anything. That's almost as good. If you don't have anything, it's possible that we might have double spending, where we come to different consensuses, which isn't a consensus. And this can happen when there are ledgers where if you can partition the network, you can actually come to different consensuses. That would be bad. Maybe you're slightly better and you have BFT, which says, well, at least we'll come to the same agreement, but we might get shut down. We might have unfairness in various ways that is bad. Asynchronous BFT, ABFT, says we will come to a conclusion, a consensus. We will know that we came to a consensus. There will be finality. You won't just become a little bit more sure and sure and sure over time. You will know. You will guaranteed reach that, and you will guaranteed reach that, even if attackers can shut down individual computers. Even if an attacker can build a firewall around many of your computers and stop them from communicating, or let some messages through the boundary but not other messages, or let some messages through fast but make other messages slow. If the attacker can do all these things and you're still okay, it is ABFT. So BFT means we'll come to conclusion, they'll have finality, and we'll all come to the same conclusion, and it's guaranteed to happen eventually. ABFT means it's even sure when we have these sorts of attacks. Is BFT good enough? Do we really need ABFT? Sadly, yes. Distributed denial of service attacks are a real-world thing. These are attacks where someone compromises many computers on the internet and they flood you with messages and shut you down and prevent you from talking. This happens in the real world. These are real attacks. And if your system is so fragile that shutting down one computer will shut down your whole network, that's a disaster. Maybe not when we're just playing some games right now, but when we go to using ledgers for important things in the real world, will it matter if you can shut it down for a few hours? Yes. If you could shut down all the banks in the world for a few hours, would that matter? That would be bad. If you could shut down a store, like, an online store, and the whole business shuts down for a few hours, would the business care? Yes, that would be bad. We cannot have that. We have to be able to survive DDoS attacks. Well, what if we're BFT, but we're not a BFT, but at least we take turns on which computer is the leader? Would that be good enough? No, sadly not. Because you could keep attacking different computers. The attack could switch. So we need real security, ABFT. It's hard to achieve, and speed at the same time. But that's what Hashgraph does, and that's important. Furthermore, none of this technology matters. It never matters if you do not have good governance. You need people in charge of it who are competent, know what they're doing, and are trustworthy. If you can't trust them, all the technology in the world is useless. If the technology is constantly allowing the network to split, then there are severe problems. I don't want to store the real estate records of who owns a house on the network if it's going to split. The governors need to govern it and prevent the split. Because if you could have forking that allowed splits, then you could have a ledger that remembers who owns what house, and you could use that to do title searches. You could do that to find who owns a house, but then when it splits, you have two ledgers now that remembers who owns my house. And if I sell my house, one ledger might get updated and not the other one. And then when you want to know if you can buy it, you have to find out who owns it. And it doesn't work because different ledgers say different things. We have to stop this kind of splitting. And so you need good governance that you can trust, and it needs to have the ability to govern. Very important. And so this is a distinctive thing that we have that is very important. So then, what are we going to do with this? What is our roadmap? Well, I'll tell you. Right now, we have a proof of stake system, which means the security comes down to the tokens, not proof of work, where you have to use lots of electricity on expensive computers, and they all get consolidated in one country. Instead, we'll do proof of stake, spread out. No one person controls all the money. No one country controls all the hashing power. It's well spread out. Anybody can join because you don't have to have a supercomputer, and will allow staking and proxy staking, which is very cool, which I'll talk about. We have the three services that Mance talked about: cryptocurrency, file service, smart contracts. We're optimizing for cryptocurrency to be fast and cheap because it's fast, low fees. So you can afford to send someone 1/100th of a penny maybe to read an article on a website. And we've demonstrated that on our mainnet. This is what we have. And we have optimized for these micropayments and optimized to allow you to earn by running a node or even proxy staking, even if you don't run a node. And we are allowing you to get information from the network in several ways that are important. And so for the micropayments, the fast, tiny payments, this is a copy of the daily timestamp, an actual website we've created that you can pay for with HBARs on the mainnet, a little tiny bit as you read each article, which means you don't have to be bothered with advertisements, which means if you don't have advertisements, you don't have to have someone spying on you. And you don't have to sign up for a subscription. You just pay ad hoc. Ad hoc means anytime you go to a website, if you want to read the article, you can do so. And you can pay the penny to do it or the fraction of a cent to do it. You don't have to have a subscription you signed up for. You don't have to pay them every month. You don't have to give them your credit card number. It's all just invisible and smooth and easy to do. And you have control of it. And it's not advertising, so they don't have to spy on you. It's a different way of doing things. In addition, you can earn. If you run one of the nodes, and eventually we'll allow everyone to be running nodes, you stake some of your HBARs. But you don't bond them. You don't tie them up forever. You can always spend them anytime you want. You can take them out anytime you want. It's just while they're there, they're sitting there, and they're influencing how much influence you have over the network. And Hedera pays you every day for running a node. Thank you for running the node. In addition, if you don't run the node and you have some HBARs, you can proxy stake them. You can choose one of the nodes and say, I'm sending my HBARs proxy staking to that node. And you increase how much influence it has. Again, you don't lock them up. There is no slashing. There's no way that you could ever lose your HBARs. There's no way the node could ever lose its HBARs. There's no punishments. Even if the node does bad things, we don't take its HBARs. Your HBARs are safe. We just, well, prevent it from doing bad things. It's a very resilient network. And we could make it stop being a node, but we don't take away HBARs. It's all very friendly. And then by proxy staking, there are payments that then go to you and to the node. It benefits from you doing that. And you can ask for data. You can ask the network, hey, what is my current balance? What's in this file? Has the file been deleted? And no matter which computer you ask, it can give you the answer. And it can't lie. It tells the truth. Even if it's a bad person running that computer, they have to tell you the truth. You know why? Because they give you a state proof, and it's cryptographically secure. It shows that whatever answer they're telling you, the whole network agreed on. It's not just their opinion. So they can't lie because of the state proof. And you can even ask questions like, has this file been deleted? And they can say, yes, it was deleted. And they give you the state proof. And they can't lie. And you can take that state proof to a third party. You could take it to a court and prove that the file was deleted. So you maybe have an obligation to tell the world information, like a quarterly report for your company. You can put it on the ledger and get a proof that you can show others, yes, I really did release that information. And then maybe when you're supposed to delete it with GDPR, you can prove that you deleted it, and you can prove to a third party. This is a whole new way of handling data from a ledger, and you can do this. Furthermore, you don't have to ask a node on the ledger, you could ask a mirror net node. We're setting up a way, this is on our roadmap, of creating a mirror net. Even more nodes that aren't involved in consensus, but they are getting a complete copy of everything that happens on the network, a complete mirror of all the data. And then they could give you this data. Maybe they give it to you cheaper, or maybe they give it to you for free, or maybe you run a mirror node and you get all the information. Maybe they decide to store historical information and can tell you about the past. There's whole business models that could be run on mirror nodes. And this is on our roadmap, for we will be building this year, we expect. Lots of interesting things you can do with these mirror nodes. And they increase the transparency. There is nothing secret and evil that the network could do that you wouldn't know about, because the mirror nodes can see all your software, they're running the software, and they can see what's going on in the network and track whether it's actually doing what it said it would do. There is no way the council even could fool people into thinking it's doing something it isn't. Total transparency from the mirror nodes. And I said it has new businesses that it enables. There's all sorts of uses for it, and it's secure. We will also, I keep talking about the network as being all these computers that see your transaction, but as we grow, we'll have shards. We'll break it up into pieces. And because each shard is running Hashgraph, which is ABFT, very, very secure, and has state proofs, it can talk to other shards and show them state proofs. And so when we glue them together, the whole network is ABFT. And if one shard is fast because it's running Hashgraph, then when we glue them together in a way that the whole network is even faster. If one is trustworthy because of the way we're building this, all of them will be trustworthy. And if you get finality in one shard because we're running Hashgraph, the whole system will have finality. And so this is ideal for building a sharded system. So I told you that Hashgraph was kind of running at the limits of what the internet would allow and what the laws of mathematics would allow for speed. It's more or less as fast as you can get for consensus in a single shard. But what if you want to get faster than the laws of mathematics allow? That's sharding. You can be faster than could be possible with one shard. And so we will grow for that. Turns out there are use cases where sharding doesn't help. That's why you want a single shard to be fast. But there are other use cases where sharding helps a lot. And so we do sharding. And so that is on our roadmap, is to add sharding as well. These are some of the things that are on the roadmap for what we're doing. We are very much, though, looking forward to you building on this foundation, building dApps on this foundation, building applications that use it, building use cases. You know we have 300 companies already building these dApps. We're talking to many more. Our council members have ideas, and I would like to invite you to be joining us on this journey and to helping us build this future. And so this is Hedera Hashgraph, and I just want to thank you. This is what we are doing. Thank you.
Another round of applause for Dr. Baird. So now that you've heard about the technology and a little bit about the Governing Council, we want to shift gears a bit. And we want to dive a little bit deeper into the Governing Council. I now want to introduce Tom Trowbridge, who's president of Hedera Hashgraph. Now, Tom Trowbridge graduated Yale University, got an MBA from Columbia. He's been investing since 1998, or even earlier. Now, he had a desire to really get his teeth into tech businesses. And so he worked at companies like Goldman Sachs, private equity. And when he met Mance and Leemon, just like Edgar did, he thought this was it. This is why he had been going through all of the experience that he went through, and he was going to dedicate himself to this business. Tom brings drive and energy and entrepreneurial spirit to Hedera Hashgraph. So I'm very, very pleased to introduce Tom Trowbridge, president of Hedera Hashgraph.
Thank you, Sammy. That's a terrific introduction. I'm going to have that happen every time I get on stage. Thank you. I'm thrilled to be up here. You know, a year ago, I had never been to South Korea. I've now been here 3 times. And I think you've heard our focus on Asia, and particularly in Korea. And I think you should expect to see the team here a lot more regularly going forward, given the importance of this market. And I think we all are thrilled to be here and look forward to coming back frequently. You know, I'm here to talk about the first 5 council members. And you know, what's particularly interesting and makes us really happy is these 5 members are from 5 different countries. And Mance mentioned the importance of diversification in our council. And I think that diversification by region and by sector is intuitive. And I think everyone here can understand that. But I want to spend a moment on time. And he also mentioned that they were diversified by time, and that a council member has maximum of 2 consecutive 3-year terms. And so at scale, a third of the council will be leaving every year. And you know, why did we do that? And why is that important? And it's important for 2 reasons. One, we want this council to be big enough to be representative, but small enough that people can actually work together. And 39 is about the upper limit that we felt was actually functional. But there's a lot of companies in the world, and 39 just will not cover it over time. But by making the council turn over, we get the opportunity for many, many more companies to join the council over the coming decades. And we feel that is very important to do. The other part of this is that we want to make sure the council is making decisions in the best interest of the whole ecosystem and of all partners and customers globally. And if you're going to be leaving the council, you probably are going to be making decisions with that in mind. And so the fact that you're going to leave and you're temporarily there and you're stewards of this network, we think will really help catalyze and inspire and drive the most consistent and long-term decision-making process. The question we get asked a lot is, what type of companies and what does it take, what do you look for to be on the council? And the answer is we look for globally known and trusted companies. And it's important that they're trusted, as has been mentioned, because they have responsibilities. They're stewards of this network. They set pricing, they set the technical product roadmap, and they manage treasury. And so we think that companies that have global brands and really have something at stake here is very important. And that was a very relevant characteristic when we were searching for council members. The question also comes, do they have to have expertise in distributed ledger? And actually the answer initially was no, they don't. But what we found is that the companies that have devoted the most resources to this technology actually understand what we are doing the best and are most likely to join. And so we've ended up with first 5 members who each have deep expertise in DLT. And I think it shouldn't have been a surprise to us that that is the case and that's how it worked. So let me first spend a moment on the first company, which is Deutsche Telekom. Deutsche Telekom is the largest telecom provider in Europe. What you may not know is their T-Labs group has 80 people focused on artificial intelligence, IoT, and distributed ledgers. They were very well positioned to know exactly what we were doing. It's actually interesting, I first spoke to John and Friedrich about Hedera Hashgraph in Korea. I was in a taxi on the way to the airport, actually, and had a scheduled call and spoke to them. They knew so much about Hedera. They understood the council very quickly, and in a very short amount of time, committed to going to the next step to understand everything they could about joining. And I got to the airport and I saw Mance and Edgar at the airport, and was like, that was such a refreshing conversation. They had done all this work. They knew exactly what we were doing, exactly who we were, and we're thrilled to have them on board. Swisscom is also understood immediately what we were doing. You're very aware of who Swisscom is. Swisscom actually has a 40-person dedicated team to distributed ledgers. They actually call it Swisscom Blockchain, so it has its own separate name and separate division, and they actually run nodes for 8 other protocols. So if you're looking for a group to really evaluate, understand your technology, that's a group that can do it pretty easily, pretty quickly, pretty reliably. And they also saw the need for governance. And so again, very quick to understand what we're doing and to commit to joining. Nomura. Nomura is a global investment bank headquartered in Japan. It was actually founded in 1925, so it is our oldest council member. They are known as one of the leading banks in Japan, and they also have significant experience in distributed ledgers. You may have read that in May, Nomura announced a program for custody of digital assets. They were the very first bank to announce such a program. So again, deep expertise in this bank about what we were doing. Magazine Luiza. Magazine Luiza is the leading technology company in Latin America. It has its roots in traditional retail, and they have over 1,000 retail locations, but they are technology innovators, and through Luiza Labs have 700 developers constantly working on technology solutions. So if we're looking for a partner in Latin America, there's no better partner and no one with a better reputation for technology innovation and deployment than Magazine Luiza. And finally, DLA Piper, one of the largest global law firms with offices in 40 countries. DLA Piper has put significant resources into understanding technology, both for its own sake, but also for its clients. It works hard so that it can understand and help its clients deploy and commercialize new cutting-edge technologies. And we're very happy to have a law firm as part of our council. I think everyone here knows the very shifting regulatory environment that we live in this space. And we think that the advice, counsel, and guidance of a global law firm with expertise in technology is going to be invaluable to Hedera as we grow and evolve over the coming years and decades. So to learn more about DLA Piper and why they joined, here is a video.
My name's Scott Thiel. I'm a partner at DLA Piper and a member of the Hedera Governing Council. My role is heading up the technology sector for the Asia region for DLA Piper. We have a very strong focus on technology, so unlike many law firms which perhaps have technology as a support function, we have it as one of the core parts of our business. The best technology lawyers aren't just the best lawyers. They're the ones that actually truly understand how technologies work, what are the options and opportunities that a particular technology may provide over a different one. And with that understanding, we can be better lawyers and we can help implement solutions for our clients that best supports their business objectives. When we looked at the Hedera technology, what we saw was a lot of answers to a lot of the problems that we're seeing our clients experiencing. Problems with speed, problems with fairness, problems with security, problems with flexibility, legal issues around compliance. We found that looking at the Hedera model, a lot of those existing challenges were being solved. For us, the ability to get in and understand this technology, to be able to help with our experience frame some of the answers to some of those questions that our clients have, was a really exciting opportunity. We then, having explored that technology to the point of this is exciting, we'd like to talk to our clients about building solutions on this technology, we then learned about the council and we learned about our ability to participate in a forum in which a number of experts from different industries, from different sectors, were going to be able to come together and leverage a global view of how this technology could best be adopted for future implementation. Becoming a member of the Hedera Governing Council is giving us a deep understanding of the way this technology is likely to be adopted. It's going to help us participate in a new ecosystem and in a sector that we expect to expand rapidly in the next few years. It's critical for us to leverage technologies such as Hedera to build these solutions that we can then take to our clients, allow them to do more creative things with their assets, to build different business models. And it's for us as lawyers, we need to find partners such as Hedera in order to build those use cases using that tech and our knowledge. That's going to be, I think, where we see a fundamental shift in the legal market in the next few years.
Please join me in welcoming Scott Thiel.
Good evening. Thank you very much for the people in the room for being here and for those online who are watching the live stream. I'd also like to start out almost first and foremost with a special thanks to the Hedera Hashgraph team for the opportunity to be here this evening and to participate in this very exciting project. So I thought I would talk tonight about our journey, how we ended up here, how a law firm indeed ended up here tonight, looking at the key issues that we've gone through, and I'm going to use asset tokenization as something of a case study as to why this has happened. So the drivers for change in our business are significant. As a lawyer, I get the privilege of actually working with a lot of clients from different sectors, from different geographies, and what we're seeing across that broad spectrum is a genuine desire to implement blockchain technologies, to the point that we believe within our organisation that it is going to be a game-changer technology, something that we will see more and more adoption of. DLA Piper has a very long history of supporting clients with technology innovation and adoption of technology, so we're well placed to support with this next trend. We're also seeing our clients and market forces driving significant change in the way our business is going to have to operate. We too are going to be impacted by these developments, and we're going to have to evolve. So I want to use this case study, and it comes from our client listening program, unique perhaps for lawyers to listen to clients. But we went out and we asked them, what are the challenges? What are the things that you're finding difficult in your business? And one of the early use cases that we've identified is owners of commercial real estate. So people who might own a large building, let's say a $100 million building. What can they do with it? What would they like to do with it? What are the frustrations with that? And there was a consistent theme when we talked to that sector about a lack of flexibility. I've got a very expensive asset. It's hard to deal with. It costs a lot of taxes to talk to a land registry office to move it around. It takes a long time to do that. There are corporate models that try and deal with these issues by moving the asset into a corporate vehicle, but then corporate registries slow down the process of transferring shares and interests in that entity. Liquidity is a problem as a result of all of that red tape that needs to be gone through. And even if you manage to find somebody with $100 million to buy your asset, as a fund or as an owner, you need to return very quickly to the market with that large amount of cash. And again, that can be difficult to find the next opportunity. Plus, there's a limited investor pool. You're talking about people who have that much cash sitting around to deal with your asset. So that was the problem. DLA Piper has built a trusted, transparent real estate conveyancing platform. It facilitates private transfers of tokens which sit and are issued by an asset, by an entity that owns the real estate asset. It's secure and transparent. We've actually developed that and now re-platformed it onto the Hedera network, and we're looking forward to the network continuing to develop so we can deploy that solution in a more live environment. And our clients are very interested in talking about that. So that's one example of a use case that we're seeing a lot of interest in. We've also looked at a number of others and are in development around those. So real estate was great. That was an obvious use case. What we're already finding is clients coming to us saying, oh, you could tokenize my real estate asset. What about some other asset? Debt books, for example, or other assets. And so we're seeing a lot of interest around how do we create secondary markets by taking one of our clients' pieces of infrastructure or a book of debt or a loan book and then fractionalizing that into tokens and then trading it off the registers in different ways. We're also a very large law firm in the area of intellectual property. Many of our clients have extensive intellectual property portfolios. They have challenges, as we all know, copyright theft, misappropriation, pirating, lots of issues that people are familiar with in terms of how you commercialize your IP assets. And one of the challenges for that is it's quite clunky. You tend to have to do a large mainstream licensing deal, again with a very large player. But if we can create a micropayments solution which allows users of copyrighted materials to buy on a cost-effective one-off basis, then there's a whole new market for our rights holders to try and commercialize those assets. Law enforcement, evidence management, tracking evidence, making sure it's admissible. That will be hugely supportive of both criminal cases and also civil litigation cases. Healthcare is a fascinating sector, and again, we have lots of clients there. Imagine a real-time insurance solution where you go to your doctor and before you've left the clinic, you've already had your insurance paid. That sounds nice. So portable data is another area. People will have heard of the General Data Protection Regulation, GDPR, in Europe. It creates lots of challenges for organisations, one of which is you have to be able to quickly and readily move customer data away to another service provider if those customers demand it. A blockchain-based solution will be able to do that in a cost-effective way. Lots of applications in government, citizenship validation, expedited entry, customs issues, tracking ownership and eligibility, gun safety as a result of that is another good example. AI and forecasting. A lot of our clients are doing work in the area of targeted marketing and forecasting user experience. Education, certification verification. automotive, supply chain provenance, and not just automotive as well, but there are other sectors like food safety, knowing what ingredients have gone into a product if there's a safety issue in a product recall. Energy, smart cities, smart grids, peer-to-peer, off-grid lending arrangements, great opportunity. And financial and banking, which I'll leave some of the other council members to touch on in more detail. So why? This is good. We have a problem that our clients want solved. We have a solution in the form of blockchain that looks like it could be useful. And we have the focus and interest in helping our clients to deploy those in a legally compliant manner. So why this particular technology? Well, the answer is simple. When we looked at those use cases, they matched up very well with the attributes of the Hedera platform and the underlying Hashgraph algorithm. Secure, scalable, stable, fast and fair. Leemon touched on the idea of putting a real estate asset on one of these things and finding there are two versions of the truth. That can't happen for real-world major assets. So it's essential that we have things like the no forking guarantee. Then there was the participation in the future, the ability to participate in the council and to join a number of other world-leading organisations and bring our expertise to that. So legal compliance is one of them. My colleague who's in the audience tonight, Mark Radcliffe from my Palo Alto office, is an extremely experienced in the area of technology consortias. And it was great to have, sitting next to Mark yesterday in the council meeting, to hear about how his experiences in those other consortia is going to be valuable here and to learn from that. Then perhaps the most interesting thing of all, though, was to actually get together with the other council members, and we're looking forward to there being more of those in due course, and to work collaboratively with them. Perhaps one of the most interesting parts of the first meeting yesterday was when we had a brainstorming session. What are the use cases you're thinking about? And it was truly fascinating to see what went up on the board, the depth of thinking that had gone into it, the diversity of applications and solutions that our fellow council members were thinking about. So I think what we're going to be able to do by participating in this is leverage that expertise, work with our clients, and we have a ready-made consortia of members we can go to, again, to participate with how are we going to build these solutions? How are we going to build it together? We're just a law firm. We have an important role to play, but it surely isn't the only role. And this is a great opportunity for us to be able to work with other world leaders in this area. My experience on the council yesterday reminded me of an African proverb that I particularly like. And it goes like this. If you want to go fast, go alone. And if you want to go far, go together. Thank you for listening.
Thank you very much, Scott Thiel. Another round of applause for Scott Thiel. What a fantastic proverb. We are so honored and blessed to have a council member like Scott and DLA Piper. And now I want to introduce you to a few more of our initial governing council members. And I also want to, at the same time, introduce another colleague of ours, Zenobia Godschalk. Now tonight, you've been hearing about our technology. But really, what we are telling you is a story. A story of how we began, of where we are, and of where we're going. And this is such a new field that really bringing out the story of the technology is the key for us to bring it to market, to grow the ecosystem, to bring in governing council members. You have been seeing videos, you have been seeing the production, and the next moderator of the panel, Zenobia Godschalk, has been instrumental in working with us to create this story so we can continue growing our ecosystem. So please, ladies and gentlemen, welcome Zenobia Godschalk, our VP of Communications.
Thank you, Sammy. Annyeonghaseyo. Good evening. Hello. Thank you to everyone in the audience here, and hello to everyone on the live stream. We really appreciate you joining us, no matter what time of day or night it might be for you. Tonight, I have the distinct honor of interviewing a few of our council members who have traveled so far to be with us. These folks are leaders in their industry, they are visionaries, and they are helping their companies and their customers usher in the future. So I'm going to bring them on stage, and then we will have them each share a little bit more about themselves and what their companies are doing. So first, we have Kamal Youssefi with Swisscom Blockchain. Thank you, Kamal. And next, we have Friedrich Kurz with Deutsche Telekom. Thank you. All right, again, thank you both so much for coming all this way. We really appreciate it. And we are so excited to welcome you both to the Hedera Governing Council.
Thanks for having us.
Absolutely. Kamal, to start, why don't you just give us a little bit of background on yourself and your role at Swisscom Blockchain?
For sure. Hi, everyone. Kamal Youssefi is my name, and I'm leading enterprise blockchain advisory within Swisscom Blockchain. Swisscom Blockchain is a subsidiary of Swisscom, the Swiss national telco operator and largest ICT infrastructure within Switzerland. Swisscom Blockchain is a kind of one-stop shop for blockchain, which offers a pack of advanced solutions and services to ensure a secure implementation of different blockchain use cases across the industries.
Great, thank you. And Friedrich, similarly, if you can share your role and what you do with DT.
Sure, thanks for having us here. Thank you, everybody. So my name is Friedrich Kurz. I'm heading the Global Partnership Program at Deutsche Telekom T-Labs in Berlin. I got a background as an IT and IP lawyer, as my fellow council members here as well, and spent half of my career in court, and the other half I'm trying to build up partnerships. So I'm very excited to be here.
Good, good. So Kamal, Swisscom Blockchain is a subsidiary of Swisscom. Why did the company think it was so important to stand up an organization specifically focused on blockchain and distributed ledgers?
Well, building a connected world between individuals and corporates has been always and still being the prio number one within Swisscom. And if you look at blockchain or distributed or distributed ledger technologies in general, it has the potential to enable new business models and create new ecosystems across almost all industries. And on the other hand, ensure a valuable implementation of blockchain use cases and solutions requires deep understanding of technology, professionalism in business advisory, and also a dedicated team who's going to focus on the development and evaluating the use cases. Swisscom decided to create a subsidiary or a new company within Swisscom to focus on that and bring all these aspects and the required skill set to cover all these aspects together. So that's why they created Swisscom Blockchain.
Good. And so how do you work with the other groups within Swisscom?
I mean, Swisscom is a very big company with more than 23,000 employees. We strongly believe in collaboration and cooperation, not only across the different departments and business units, but also across the individuals. So that's why we always create a kind of joint task force across all the departments and business units to set up a cross-functional team and make sure that the project team has the needed skill set to transform the projects successfully.
Thank you. Friedrich, you advise DT and your customers on uses of DLT. What is most interesting to you these days?
So this is right. So very interesting for us is now that the hype is gone around cryptocurrencies and that the dust settles. We see which companies and organizations really did do work and build something meaningful. And I think Hedera Hashgraph, you definitely did that. And the others who only were in speculative mode here. So, and this is very good to see that now we get a little bit more visibility on which technology is applicable and which one is not.
And are you seeing some consistent, challenges to adoption or questions to adoption?
Absolutely. So we made a survey 1.5 years ago under our dear customers, business customers, and we saw a lot of uncertainty regarding the underlying technologies. Nobody knew exactly on which blockchain, DLT, where shall I build it, how could it work, what is a fork, what the hell happens to my customer data if it happens. So, and this is of course something what really, really slowed down also the application of DLTs in the space, but we are on it. So we are looking in different models and alternatives very much here also in Hedera, but also trying to find interoperability solutions.
Great. And that brings up a good point. We have talked a little bit, Kamal, about public and private ledgers and how people are thinking about bringing those two things together. Can you share a little bit with our audience some of the instances where you're seeing this happen?
Yeah, for sure. I mean, within Swisscom, in general, we are committed to equip enterprise and corporate customers with the crypto infrastructure. And we have been facing these challenges where different clients were interested in different blockchain platforms. And some of them were public blockchain platforms, some of them were private ones, and some other corporates were interested more in hybrid solutions like hybrid blockchain platforms. And that's why we started thinking about creating a new layer where we can develop a kind of orchestration layer between all the different blockchain platforms and get them to communicate and synchronize each other. So I'm glad that you mentioned the same experience in Germany as well.
Friedrich, do you want to elaborate a little bit on your experiences here too?
Absolutely, so glad to do this. So we looked into this a little bit deeper also, and we saw that one of the underlying problems is that you have this uncertainty on the one side, and on the other side you want to build something meaningful towards your customer. So as a developer, usually you don't have the time to consider all the time on which computer platform are you building stuff. And I think this is a parallel now to the world of DLTs, that this uncertainty can't happen. I mean, you don't have the time to do it, otherwise you are not going to go to market anytime soon. So, and this is why I'm so excited also about Hedera's approach to this problem, because this is now one of the few models where you can really have something as reliable and trustful and also powerful.
Great. Kamal, you previously shared a story with me about a project that you are working on within your group around international remittances. And I think for anyone who has family or friends around the world, that's something that, probably a lot of us have experienced. How do you send money cross-border without, Western Union or MoneyGram or someone else taking a large chunk of that? So can you share a little bit with our audience how you see DLT playing a role in these international remittances going forward?
For sure. I mean, as probably you know, the international remittance is one of the biggest challenges we had or we have been facing all the time in terms of transparency, transaction fees, and security. And during our or during the blockchain symposium in the Middle East, especially in Sultanate of Oman, we have been conducting different workshops with different ministries and some representatives from the government and they have been addressing different issues, and they were seeking for solutions by leveraging the technology and focusing on distributed ledger technologies. Sorry. And we have been analyzing the international remittance in Oman, and the use case is very simple. In this country, more than 50% are guest workers. So they are coming from India, Pakistan, and other countries, and they work in Sultanate of Oman and try to help their friends, families, relatives by sending money back. And the problem is, in their home countries, they're still suffering under the lack of the infrastructure. So the most used method to transfer money there was like Western Union and MoneyGram. And sometimes the transaction fees are up to 15%, which is huge. And that's why we started on working on the international remittance use case, which was designed and developed by addressing the potential of blockchain-driven payments, and also addressing the challenges involving the transaction speed, transparency, and the huge transaction costs associated with cross-border payments. And very good news, last week we managed to successfully perform a transaction to India within less than 2 minutes and less than 50 basis points. So with other words, like less than 1% transaction fee, or half.
Yeah, that's very exciting and a very interesting application that has a lot of impact on a lot of people, potentially.
It covers also a human aspect, so that's the beautiful thing in it.
Yeah, absolutely. And Friedrich, we have talked a little bit about call data records, which for those of us in the audience who are not familiar with that terminology, maybe you can share a little bit about what that means, why that's so important for your industry, and maybe a little bit about how antiquated that process is today.
So happy to do this. So call data records are basically the metadata of each call. And the metadata of each call are then written to a file, and that's called CDR. And in this CDR, you see the callee, the caller, and also the length and duration. So, and the fun part of it is like the many telecom providers in the world, each and every one has its own format to do this, believe it or not. So it's hard, there's no standard setting organization is on it, so it's really something what then only works with people in the middle of it that extract the data from the one CDR and from the other CDR and match it. So, and because this is such an antique way to do it, there's a lot of opportunity for fraud also and for mistakes. And this is actually a huge problem in the industry, and there's a lot of money that is lost by this. And this is one of the points where we see distributed ledger technology as something what has to be adopted very fast, very quickly.
And I think you gave the example of, you know, if I'm roaming here in Korea, then my provider has to somehow reconcile that with, you know, the Korean telecom that is providing the service here. So for those of us traveling quite a bit, I'm sure we don't see that in the back end, but you have to deal with that.
Right. With the pen and paper process, basically, right? The agreements that are underwritten, so it's amazing.
Wow, maybe some squirrels in the background as well. You know, now it's one thing, both of you have joined the council, it's certainly one thing to be using distributed ledgers and to be thinking about how to apply that to your business. It's quite another thing to actually say, I want to have a role and a voice in a governing council for a public ledger. Kamal, maybe you can share a little bit about why you chose to do that and why Swisscom is interested in having a seat at the table.
Well, as part of our commitment in the DLT era, we are supporting effective and secure implementation of blockchain use cases, and we also support blockchain use cases that demonstrate the value proposition of the underlying technology. And we have been always looking for a blockchain platform which implements the most relevant aspects of a blockchain platform, which are speed, fairness, security, and scalability. And I'm really happy and proud to be part of the Governing Council so that I can help by sharing my experience, by sharing industry insights, and drive together the product development towards the future.
Great. And Friedrich, why did DT decide that this was, something where, again, you wanted to have a seat at the table?
Right, so we had two drivers, basically. The initial one was we wanted to have a say in the technical development and the technical roadmap. This is also what my dear colleague from Berlin already said in the video. This was one part, but the other part that has then gained also on way is like sitting together with those council members and discussing really interesting stuff. And so I remember our initial meeting yesterday, and it was like really very interesting how so much expertise at one table rolls up the sleeves and goes to work and actually does something meaningful. So, and this is something very, very exciting.
Good, good. And, there are a number of committees that will be organized and manage different parts of the governance. So I think Scott talked a little bit about, technical committee, business committees, legal, finance, marketing. Friedrich, which committees in particular are you and your colleagues at DT interested in serving on?
Actually, I find each and every committee fascinating.
Perfect.
Really.
Yeah. Sign you up for all of them.
But no, I can't. So in the end, I have to make a decision. And of course, the legal and regulatory comes handy. But I mean, also the technical committee and also the membership committee. Every one of those is very interesting for us.
And Kamal, how about you and your colleagues? Where do you see yourselves participating?
Well, first of all, I'm going to speak for myself. So I already committed myself to be part of the technology committee, as I would like to see the product development and actively contribute to shaping up the future. However, I committed myself as well to share the industry insights coming from Switzerland to ensure or make sure that Hedera Hashgraph is gonna address the business needs.
Good, good. Well, we're glad to see such active participation already from some of our initial council members. Again, we want to thank you both so much for coming all the way to Seoul. Again, to our folks on the live stream, thank you for joining us. And yes, our gratitude and our appreciation. Let's give our panelists a big round of applause.
So that's it, guys. I hope you guys enjoyed. And as we wrap up the first portion of the night, I just want to remind everybody, there's a reason why we wanted this to be an invite-only event. And the reason is because of the second portion of the night. We have drinks ready in the back. We have food ready. And we hope that we can speak to as many people as possible. I'm sure there'll be a line behind Dr. Baird, but please, if everybody can, actually before that, I have to make sure I acknowledge the live stream. Thank you so much for being with us, wherever you are, different time zones. I hope that you could feel the energy and the enthusiasm even through the computer screen. So at that, I want to close the event. Everybody excited for the food and drinks? Yeah. Please, if you can stand up, head to the back of the room, and enjoy the food and drinks. Thanks, everybody.